Hi guys. Good evening, all of you. And today we'll be doing an interesting problem on like past year ISI MStat paper, and we will try to do some simulations live in R. So, and also I have some other problems in my radar of thought. So let's get started, guys. Coming back to the problem. This problem is I gave this as homework for the Monday class this week. So this problem, we have just completed the discrete distributions, and we have just we will, for this week we will be doing problems on discrete distributions. So we will be doing this problem. Let's start with this basic problem. It's a problem from ISI MStat 2013, problem number 9. So the problem is the following. Did you guys try out this problem as a homework from the Monday class, guys? Did you? Oh, you forgot. Okay, Tishika tried. Fine. So let's check it out. Okay. And the problem asks you that you have their chips on cell, and each chip contains exactly one toy, and which can be of the 4 types with equal probability. Suppose you keep on buying chips, like their chips, and each of those chips there are 4 toys with equal probability. Okay, but you keep on buying chips and stop when you collect all the 4 types of toys. Okay, so it's like this, that so you see there's a hint of a geometric distribution in this, because whenever there's a stopping time criteria that you stop when you get this, that's exactly where you get a hint of geometric distribution and negative binomial distribution. So let's understand this, guys. So if each chips, understand this very carefully, that each chips probability is 1/4. So any ideas like how will you approach this problem, guys? Any ideas? Tishika, how did you approach this problem? You made 4 cases, okay, and then you take 4 cases, and so you can understand that one thing. Let's say you get, so there are 4 toys, say T1, T2, T3, T4. So let's say you get the first toy. So what exactly is left? So if you get the first toy, what exactly is left? You are left with the 3 toys to come, right? So what do you do exactly here? Yeah, so perfect. You're right, Tishika. So the idea is very simple. There are 4 toys. T1, T2, T3, T4, and there are chips per cell. So let's take the time. Let's see the time to reach the first toy. Let's say T1. Let's see what time is required to reach the first toy, and the number of chips to buy. Here, each chips buying is each step. The number of chips to buy. Observe that number of chips to buy to get the first toy. Can you guys tell me what distribution does it follow? Can you guys tell me what distribution does it follow? Geometric. Perfect. Because it's just like you can understand the number of trials required to get to the first success. It's sort of that idea. But with what probability, guys? With what probability, guys? Tell me. 1/4, because there are 4 toys. Perfect. So the number of chips to buy to get to the first toy follows geometric 0.25, rather 1 by 4. Okay, perfectly good. And now you have bought the first toy. Now you have bought the first toy. And now let's go to the, as Tishika has told, let's go to the second case. When you have bought the first toy, and now you need to, given that you have bought the first toy, now you need to go to the second toy, T2, to get to T1. Now, this is a beautiful property of geometry you're using over here. It's called the memoryless property of geometric distribution we are using. So understand the number of steps, the number of chips required to get to the second toy is what? Tell me. Number of steps. Now you will know this is a geometric property you were using. Number of, now the probability of getting that thing will be what? Tell me, guys. Tell me. Any ideas? What will you do? Next, the next probability का क्या होगा? It will follow geometric 1 by 4. Right? Or 1 by 3. Tell me. It will follow geometric 1 by 4 or 1 by 3. Tell me, guys. What will you do over here? It will follow geometric 1 by 4 or 1 by 3. So you are buying chips. Each chips contain one toy, which can be 4 types with equal probability. Now you keep on buying chips and stop when you collect all the 4 type of toys. So you see,
So we are conditioning the fact that like T2 has not appeared till the time we got T1.
yeah, you're right.
So
Or
we follow geometric 1 by 4, right?
no, but think about the cases when T2 have occurred before. So what will we do? So you think about the cases when, like, let's say in the first toss, like the first chips you have bought, you already got T2 during this time. So why will consider this over here? That's my question to you. You understand? So till you buy T1, till you get the first T1, you have already got maybe the previous ones. It can happen, right? It can happen, right?
So can we do it like this? Like T1, T2, T3, and T4 are all independent.
Yeah.
So if we consider separate cases, like for T1, it will follow geometric. Similarly for T2, T3, and T4.
So you're telling you need exactly for like 1 by 1 second. Yeah, you need exactly 1 by 4. That is 16 chips to get all the toys at least once. Or you're telling that? You're telling that, guys? Tishika, this is how you met? This is how I made it. Okay, let's do the simulation in R. Okay, let's do the simulation in R and check what will be the answer. Okay, let's take a simulation in R and do that. Are you all okay with it, guys? Are you all okay with it? Let's do a simulation in R. Yeah. So and understand whether Sneha is telling that we need 16 cases. So 1 by 4, it will first geometric will be getting the first toy, the second geometric will be getting the second toy, okay, and the third geometric will be getting the third toy, and the fourth geometry will be getting the fourth toy. But when you get to the first toy, guys, then automatically you can get to the previously the other toys, right? That's my question. That's my question to you. Like, let's see what R has to say. What is a real life simulation say? Okay, let's do it, guys. Okay, so let's understand the parameters also. So I've already made the code for you in our website, but we will do it again over here. Understand this, that here is the code. So we are taking n, so the number of toys is n equal to 4 over here. Okay. So what we are doing is that we need to like understand this over here, that for I in 1 to 100, we are taking a sample of 4. Okay, what exactly we're trying to understand here, what exactly we are doing over here. For I will just make you understand this step by step. For I in 1 to 100, okay, so what exactly we are doing, we are seeing that from how many tosses we are getting all the toys, okay. So initially we have 0 0 0 n equal to 4 toys. So let's see what is this. In it is 0 0 0. Okay, toy is 0 0 0. What we are exactly doing, initially we are technically storing that how many like initially it has the number of like the toy numbers, how many we have initially got. Okay, I will check that. Okay, and for I in 1 to 100, we're taking a sample of 4 to 1. What is the sample of 4 to 1? Let's understand that. 4 comma 1, it's like out of 1 2 3 4, we are taking a sample 1. That is it's like sort of discrete uniform 1 by discrete uniform 1 comma 2 comma 3 comma 4. That exactly we are doing. Okay, and okay, can we make a little bit, let's see, I can zoom in a bit. View, zoom in. Yeah. So we are sampling, taking a sample. We are checking that which which toy we are getting in the first. We are getting 2, right? So what we are doing, we are taking therefore the toy. The toy is the second number. So we have got S. So toy ka second vector, we will get +1. Okay. That means what will happen? Toy dekho. So see that we have got 1 at least 2. So we go to the next toss, n plus 1, and we are checking that if toy is greater than initial, like initial or greater than initial means this will be toy is greater than initial means all of them are greater than 1, all of them are greater than 0, that at least one of them is greater than equal. This is checking actually whether this condition is checking whether we have reached the we have got at least one toy or not. Okay, we have got at least one toy or not. It's checking. This is the way it's checking. And then if it's, then we are breaking the loop.
Sir, excuse me.
Yeah, bolo.
So whether we got at least one toy or not of each type.
yeah, here we are understanding that whether we have got at least one or not. So if at least if one of them is 0, this will not be greater than init. So x is greater than y when there are two vectors in R, means x is individual greater than each of the individual elements. Okay. That means
Okay.
initially it's 0, 0, 0, the init one. So a toy must be greater than init if and only if each one of them is greater than or equal to 1. That's the meaning. So it's a condition that we have got at least one of each toy. That's we are checking every single step. Okay. So an n equal to n plus 1 is what? N equal to n plus 1 is calculating the number of steps required. Okay. N is equal to 0 means the number of steps required to get to the number of steps required to get to the first toss, to the first this condition, whether we have got at least one toy or not. So what we are doing, we are taking, so I'm sure within 100 we will get it. So I'm taking a sample, a sample chips, okay, and we are observing, this is the observing part that we have got, observing which toy we have got, and this is actually counting and increasing the, it's counting the step number that we have reached. This is the idea. So this is the random variable we need. Okay, this is the actual random variable we need. The number of the chips number. Excuse me. This is the. Did you understand this, guys? Did you understand this? How we did this, guys? Did you understand this? All of you. So the initial for loop. So we are checking this, and for this we are checking one for loop. Okay. This is where we are breaking. Okay. Let's do it once. Yeah. Oh, n is not defined. And check that data should not found. Oh, I
So
see.
true command I will run.
हाँ, टू को डिफाइन कर दिया हमने आप पे पहले. ठीक है ठीक है ठीक है. नहीं नहीं, ट्रू डिफाइन कर दिया कि n ट्रूज है, मतलब all of them are true actually. Fine. Yeah. So let's check n. So we have got 5 steps. 5 steps में ये आ गया. Okay, all of you understood that this is one loop means how many toys we are getting. All of you understood this, guys? Did you understand this? Did you understand this, guys? That this is actually a geometric distribution happening over here. Okay. So now what we will do, we will actually understand that we will do it multiple times, okay, to see the distribution of that, to see the average of that. Okay. So we'll do it, this experiment we'll do 1,000 times, 10,000 times. Okay. And every single time after the experiment, we are defining the, so V is actually calculating the number of steps. So you'll see this, like J is the number of experiments, doing the experiment again and again. What is V? It will be calculating the number of, the distribution of, like calculating the data of the number of chips in each experiment. Not calculating, storing. Hola. This is storing. And here capital N equal to 0 is actually number of steps in each experiment. Initially, it's the base case for comparison. toy is actually used for storing the data of toys we have got. Again, true is for this check. So have you understood this, guys? What's really happening over here? All of you understood this? We're doing the experiment over and over again, and we are getting this. Okay, did you understand this? Mayur, Aishwarya, Nasir, Palash, Polame, Pratiksha, Priyansh, Prama, Tishika, and Sneha. Did you understand what we're doing over here? Which part did you understand, Tishika? Bolo.
If condition जो identical twice greater than init part.
Okay, so identical twice greater than init wala part means we are checking. So true is actually, if you understand what is true, true is actually n times we are getting the true case. So let's take two vectors. Okay, x is equal to c of 2 1 2 and 3, and let's take y is equal to c of 8 2 and 0. Okay, and let's take z is equal to c of 1 0 0 0. Okay, so if we do this, what's an identical function? I will just check it out for you. It's check whether two x and y are identical or not. Okay, it's check whether x and y are identical or not. Two vectors are identical or not. So identical of this x and x over here is true if x and y is not true. Did you understand this, Tishika? Two vectors x and y are identical or not. It checks that and returns a Boolean value, true or false. Now, here we are understanding x toy minus init. Toy is greater than init. This case, this will be a. So if you ask toy greater than init, this will be false, 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 right? It will give an output false, 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 because like exactly what's happening over here. Understand, like, okay, let's understand x greater than y, what it will happen. You see, it's false, false, true. X greater than y, 3 last one ke liye it's giving true, but x initial one ke liye, so it's giving a vector of true and false. So toy, if it's 1 1 1 1, then only it will give for the first time. It will be giving whether it's greater than, like, at least it is 1 or not. Did you understand?
Yes, sir.
And now true is actually like if all of them are true and it's actually equal to the true vector, that means it will give the true value. So that's then only we will break the loop and start a new loop. That's the basic idea of the whole thing. Okay, so this is how we are counting the whole thing, counting the geometric random variable over here. So we have done the experiment a lot of times. So v is this, we have got this v. So that's the distribution of v. You see how it's coming out? See the distribution of v, you see? It looks like geometric, right? So how do you understand the parameter of geometric? Let's do the mean of v. So it's coming out 8.4. It's much less than 16, you see, Sneha? So what we have understood. You see, Sneha, it's much less than 16. Right? All of you understood it's much less than 16, guys. Why is this happening, guys? So what we have understood, what was the experiment? The experiment was we keep on collecting chips till we get the, till we get the actual, like, all the 4 toys, right? Now what Sneha is telling is that we wait for the first time, get T1. We wait for the second time to get T2. Wait for the third time till get T3, and then fourth time till get T4. So what exactly is happening? Why we are losing out more cases over here? The reason we are losing out more cases is only one, is that in this, while we are reaching T1, we have already got T2. So we are losing out the time. Okay, Mayur, Aishwarya, Nasir, Palash, Polane, Pratiksha, Priyansh, Proma, and Tishika, and Sneha. All of you understood the ideas, what I told over here. Did you understand? Did you understand that we are missing out something if we consider all the four cases geometric, same parameter 1/4. Did you understand, guys? Or no? Do you need me to explain it again? Okay, thank you, Aishwarya. Okay, so this is really, really important, and okay, perfect. So let's move ahead to the theoretical explanation of this, guys. So this is why always back up whenever you're doing a problem. Don't always go by the just like intuitions and stuff. Always go by. So it's a lab, okay? So you're doing the lab over here. So that's why you should go by the lab format of this data analysis. Anyways, let's come back to that theoretical problem. We have got it's 8, right? So we have got it's 8, and we will check here what's 8 over here. Whether it's 8.4 we have got, we'll check what's true. So let's check it over here. I will now show the theoretical part where I'll do the whole thing. Yeah. Perfect. So understand this now. Proma, are you understanding? Proma is here. Proma, let me know if you're understanding or not. Okay. So we need something more. So what exactly we will do over here? Tell me, let's say for two tips. Let's say for two chips are there, two toys are there. What you will do? For two toys are there, guys. Tell me what you will do. Two toys are there. So understand, every single time you're taking you're keeping a check on the other toys, whether you've got the other toys or not. Tell me, what will you do over here? Any ideas, guys? Any ideas, bolo? You see, you will not buy 16 chips, you will buy 8 chips. You will do it in a half time, you understand? Much less. How do you calculate the success over here, guys? See, the success over here is not based on the toys. So this is how we'll do this problem. This is not the way to do it. The way to do it, you're right almost. Understand this. So what is our success? Understand what is our success here. You understand the success over here, guys. What is a success, guys? Success here is this. The first success is when you get the first new toy. That uska probability is 1/4. You will get that in 1/4 steps. That's true. The first new toy will be got in the 1/4 steps. Or is it in 1/4 step or the first step? Is it in the 1/4 step or the first step? It's in the first step only. In the first step only, you will get one type of toy, right? In the first step only, we'll get one type. Yeah, in first packet only, we'll get one type of toy. The first success is not 1/4. Try to understand this. So in the first step only, we'll get one toy, new toy. Now the new success begins. Now in the next one, you will get this toy or new toy. You understand? So what is the success now? In the next step, you get this toy or the new toy. So what is the success now, guys? What is the success probability now? 1 by? What is the success probability now? 3/4, right? Three by four, right, guys? Yes, success probability 3/4. Perfect. Here it is 4/4. probability this. The next success probability is 3 by 4. The next success probability is what? You have got 2 toys now in your arsenal. So you will get a success only when you get a new toy. 2 by 4 is a new success now. Right, guys? And then a new success is what? The last success is 1 by 4. It's reverse. You see, it's reverse. Tishika, did you understand now why it's actually what is the parameter over here, guys?
Yes, sir. No, I got it.
All of you understood it. It's a really interesting problem, right? So you have to understand what's really going on. What is the success to you? So therefore, it will be what? The number of tosses required will be what? 1 by p. So 4 by 4 plus 4 by 3 plus 4 by 2 plus 4 by 1. So it will be 4 into 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. This comes from geometric. Let me do the problem mathematically. So understand that, let's take n1. n1 is the number of steps to get to the first success. The first success ka probability is 4 by 4 because all the 4 toys are new. It's equal to 1. So number of steps is, expected number of steps is 1, right? 1 by p, which is 1. Because n1 follows geometric p. Now all of these steps are independent. Each you have forgotten the step. So you have got the first step, you have got the first success. Now let's check the second case, second step. Now the second success comes when you get the next new toy. Here, due to the memoryless property of geometric, this follows geometric 1. Here it follows, due to the memoryless property, it follows geometric 3 by 4. And again, after the memoryless property of geometric, again follow next one, geometric 3 by 4 and 2 by 4. And finally, in the final step, you will get final success, that is, this is the n2, this is the n1, this is the n3, this is the n4. We are adding it up, and each of them are individually geometric because of the property of memoryless property. Okay, we get the final success, all the 4 tosses. So we get around 4 into 1 plus half plus 1/3 plus 1/4. So Sneha, can you tell me, like, since you have told 16, can you tell me what is the number over here? What is the number over here? Or what is the number of steps, expected number of steps? This is the expected number we have got. We have done by simulation in R, right? Can you tell me the expected number of steps? So Sneha has told that we need, if we take 1 by 4 probability, that means we would have taken what? For n number of tosses, for n number of toys, by normal logic, initial logic, like if we do ekdam bad optimization, we will need at least 1 by 4, 1 by 4, 1 by 4, 1 by 4, that is 4n, right? By this new method, we have got what? Not only 4n, I think n square, I guess, right? N toys, so 1 by n. So each follows probability 1 by n, so n into n times n square. N number of toys mean n square. We have got 16 therefore. And here in this method, we have got n into summation of I by n, I from 1 to n. This is what we have got, right? So let's try to understand this mathematically. Where does this go? This is the beautiful idea. This is the connection between, like, this thing is not done in the post of ISI MStat, but we also understand real analysis over here. So in one case, the first case that Sneha has told, the number of steps is n square, right? Let's say. In the second case, this is what you will do when you will. So suppose you get into get into a company, okay, or you get into a like any optimization, anything, right? So you say 20. Yeah, in this case, you understand 25 by 3. We have got the result. 25 by 3 is 8.10. That is 8.3 around कुछ आएगा, 8.33 ऐसा कुछ आएगा. So it's close to 8.4, right? That's exactly we have got in our. That exactly we have got, right? If this was a picture in our R coding that we have done, this was a picture. The average which will come out to be 8.4. 8.4 it was. Okay, all of you satisfied that we have done the math correctly? Do you feel more good now when you have seen the simulation? Do you understand it better, guys? So, yeah. Do you do this kind of simulation while doing the problems in your own place? Like when you are doing the whole thing yourself? Yeah, thank you, Aishwarya, for the boom. Yes, I hope you understood that better. Yeah. So this is the beautiful idea about the whole thing. Okay, all of you understood it, guys? All of you understood it? Any doubts, guys? Polomi, did you understand it? Pratiksha, Priyansh, Proma. So did you expect a 16 as the answer or less than 16 as the answer? Tell me. Pratiksha, bolo, bol. What did you expect intuitively? Proma, Nasir, bolo. No. Thank you for it, Nasir. I was just asking you what did you expect, because this was important for your mathematical and statistical mind. Logically, it seems like we need less than 16 steps, right? Okay, you first saw who did first think 16? Who did first think 16? Tell me. Who did first think 16? Okay, Aishwarya, Pratiksha, Nasir, Palash. Okay, you first thought it's 16, but you can understand it's almost half of it. Okay, so now we will calculate using real analysis and using real like mathematics to show that how much this new thing is better than the previous one. So in the first step, you understood by the natural cases, if there are n tosses and n chips, did you understand we will get n square, we will need n square steps on average? Did you understand this case? Did you understand that if there are n tosses, we would have got n square number of steps, guys? Chips. Yeah, did you understand this? That's exactly what Sneha was telling and others. Okay, which one, Sneha? Bolo. Which one you need me to repeat? Why n square? Okay, sure. So understand that if there are n toys, by the easy, like the thing, the wrong way, the longer way, each of the ni, there will be n1, n2, n3, n steps, right? Each of this will follow what? IID geometric 1 by n, right? Since they are n toys. And some expectation of n1 plus n2 plus or nn will be what? N times expectation of n1, because all of them are IID, which is equal to n by 1 by n, which is n square. Did you understand why it's n square? Yeah, all of you understood that for the general case, for the easy case, we will need n square. we'll only get n square cases. But using the easier way that we have done, the actual way, easier way, we're getting what? We're getting n into 1 by n plus 2 by n plus dot 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 n by n. Right? We are getting this. So this is called NHN. This is called harmonic number. HHN. So we'll compare these two things. Which one is greater? We'll compare these two things mathematically now. That is n square is related to harmonic mean kaise. So it's asking that
This is happening because of the conditional case. Means we have got the first toy only. That's means the for conditioning part.
did you understand the proof over here that we have told?
Yes.
Are you sure?
Yeah, this one, the 4 by 4, then it will become 3 by 4.
Exactly. So understand, for the first step, when you are getting the first success, you will get the first success in the first case only. So now the number of possible new. So what is your success in each step? It's the number of new toys by total number. So in the first n1, number of new toys, all of them are new toys. So n by n is 1. Success probability is 1. In the second case, it's a conditioning, not the conditioning in per se. It's like, okay, I mean, there's a conditioning over here, okay?
Yeah, but you said that memoryless property means where memoryless is working.
Oh, memoryless is working in the fact that we are forgetting what happened in the past when you are trying to do the when we have got the first toy, let's say in the first chips, we are starting to do it another time again, like from the next tips. Actually, it's a geometric starting, new geometric starting. You understand? It's a new geometric starting. We are forgetting whether we have got but our success probability is changing according to our need. Our success probability is now number of new toys by total number, like this 3 by 4, because we have already got one toy. The success probability is changing now. Did you understand or not?
Yeah, the success probability is changing for what reason? Means what I could sense is because of conditioning that I have got the first toy in the first packet. So means for getting another new toy in the next packet, what will be the probability? So a conditioning is coming.
Yeah, you're right. Your conditioning is coming. You're right. You're right. But if you try to write the conditioning fact on pen and paper, okay, it will be like exactly that's where the geometric property will come up. So n2 given n1, okay. So now if you try to write it geometrically, okay, mathematically, n2 is the number of toys, number of steps. Actually, n2 is defined, in like the n2 is defined in a conditioning way only. Okay, n2 is defined as number of steps to get the new toy. This when you're telling a new toy, n2 is conditioned on n1, not n1 actually, but the fact we have got the first toy. I mean, here the conditioning is not working that way. Here the conditioning is work that we have got the first toy. That's it.
Okay, and how the memoryless property is working means by memoryless property, what we know is that it does not bother or it does not remember what has happened to the past. It's all about a new starting, a new current starting.
Yeah. So when we are getting
concerned about the past values also means which toy we have got in the past, we will not take into account that toy in future days.
the memo, yeah, you're right. Actually, yes, actually, you're right. What I try to mean is that okay, you're right. So you want me to define it logically? If you want to define it logically, you will get that the number of steps required to get to the first 4 new toy, it can be written as n1 number of steps required to get to the first new toy plus number of steps required to get to the second new toy. Okay, so I will tell you. So if you want to define this now, I mean, it will be a bit of a what should I say? Okay, so if you want to define this, let me define this like this. Xi is what? Xi is actually not Bernoulli. Xi is something else. Xi is, you see, Xi is not Bernoulli. You see the point, like the point is here, Xi is not Bernoulli over here. That's why it's not geometric per se. That's why there's a bit of an error, but you're right. Thanks for taking this up. If you understand the distribution over here, Xi is not Bernoulli, but Xi is something which is a discrete uniform. Xi is discrete uniform. That over the first toy, second toy, third toy, fourth toy. Xi is not Bernoulli. This is a uniform process, not the Bernoulli process. Okay, so we are trying to understand n is the minimum number of steps required to get to the first 4 new toys. That means okay, so okay, this is not okay. The idea is over here that what I told about the memoryless property of geometric, what I meant over there is this, that when we get to the first success, okay, actually it's not the memoryless property of geometric, but actually it's the IID of, like, the IID of the process, IIDness of the process. Like when we get to the first success now, we have got the first, what should I say, we have got the first toy, right? Now when I'm continuing the next step, we're actually forgetting the past, what we have happened. Like the experiment forgets the past, but our experiment remains the same, but our idea remains condition. You understand? Here we are starting a new, like the Xi remains same, okay, but the idea is that our thought process, the experiment we are thinking of, that the number of steps to get the second success, that remains different. That means kya bolu? Actually, till this point, so what Ptolemy asked, the question is actually, it's not the memoryless property of the geometric, but it's all about the IIDness of the entire process. You see, it's not a Bernoulli process as we have understood. It's not a Bernoulli process. It's a different type of process. Did you understand Ptolemy? Like, do you understand that point? Like, I didn't exactly understand your doubt. Like, the memoryless property of geometric, what you're saying is true, that the condition, there's a condition on the fact that we have got the first toy over here, but the experiment remains same. Like the memoryless property of geometric, by that, actually that's not true. I think it's the IIDness of the process. The IID process ke liye it's happening. We are not remembering what, like, the past is not happening again. Like That's the idea. Did you understand that Ptolemy? We're actually studying a new experiment in some sense. Did you understand that, or any doubts? Yeah, bolo Ptolemy. Yeah, probability is also getting changed. You're right. So what is happening? We are actually, so when the experiment is continuing, we are constructing newer experiments for our purpose. So it's, if you see the, if you sum of this, it is not geometric at all. But what I mean by memoryless property is that we are actually not we actually forgetting that we are what we have got in the past. We're sort of taking it new in that sense mentally. Okay, because here the experiment changes. It's a different geometry coming up. So memoryless property is actually not the correct term to say. I think it's the iodiness of the process. But Ptolemy's doubt was whether we are conditioning on the fact that whether we have got a toy or not. You're right. We are actually conditioning, but I have to check the mathematics behind it. I mean, I have to check the random variable over it. You see, when I say we have got the first toy. Okay, I think we can do it maybe. Okay.
Sir,
Yeah, bolo.
sir, as a whole, our experiment is not following geometry, right? But
It's as a whole, it will
when
not. It is not
yeah,
following geometric. You're right.
okay, okay. And when we
It's
cut
sum
some
of
few
geometric,
small
some
chunks,
distinct geometric, huh?
yeah, this four experiment inside that experiment, they are following geometry, right?
Yeah, you're right. That's the idea. In fact, it's not a Bernoulli process even. It's a discrete uniform process. Each of them are discrete uniform. This is the main difference, Ptolemy. Memoryless property would have been applied only when we conditioned on the fact that we have not got the. No, actually, this is the idea I will tell you. So when we are doing the first xi, so we are actually, I mean, we are doing it in this manner. We take the sample, like the outcome space, into two halves when we are doing that. So first, actually, the geometric here is different. You see, we convert xi into Bernoulli process. How? In the first step, we do it Bernoulli, and this is actually a deep thing. Where xi is a discrete uniform. Okay, then what we do? We take into yi Bernoulli. What is yi? Yi is, if you take a, like, it's 0 and 1 with probability. Number of new toys by total number of toys. You see, this comes from this xi ka. Then next, when we get this yi, this is actually a Bernoulli process coming up. But the Bernoulli process is changing every single time. This comes up, and then we check the first geometric, and then y dash I comes up. Okay, where the probability changes. Given that here actually what the yi dash, given yi is equal to 1. Yeah, but yi dash is actually independent. So this is yi dash. So yeah, this is exactly what we're using. Yi dash is independent of yi. Since xi are independent, this next one is independent of the previous one. This is actually what I mean by memoryless, but this is not memoryless property. Okay. So this is what memoryless. You understand Ptolemy from here? Did you understand it from here? Or no?
Yes.
Okay, are you sure, Shotti?
Yeah, means what you were considering the memoryless property, I got that.
Yeah, that's not the actual memoryless property. Okay, geometric. Yeah, I'm sorry for the wrong word. Okay, fine. So here, so let's see. So we have got two numbers, n squared and nhn. So we'll now compare these two. That is how n is related to 1 by 1 plus 1 by 2 plus around 1 by n. Okay, we'll compare these two numbers. So do you know any result? How this thing behaves? Do you know how this thing behaves? This series? Do you have any idea how this series behaves? Do you know how this? Do you have any idea? Yeah. Do you know, guys? Okay, so let's do this. Is called Riemann integration. Okay. So if you take 1 by x, this graph, let's take 1, 2, 3, 4, 5, 6, 7, 8, 9. Understand that. Let's take this division, the green division. And let's take the blue division. Let me just, this is the blue part. So you can understand that the blue region area is less than the red region, is less than the green region. Do you agree with me, guys? Do you agree with me in this aspect? Yeah. The blue region is greater than, less than the red region, greater than the, less than the green region, the area. All of you? प्रियांश, प्रोमा, स्नेहा, नासिर, मयूर, ऐसे ही बहुत like perfect. Okay, let's calculate the area of blue now. The blue area now, understand it's what? This is what? The height is 2, right? 1 by 2. So 1 by 2, this is 1 by 3. This is the height. And the base is 1, 1 by 4, 1 by 5, 1 by 6. So the blue region is 1 by 2 plus 1 by 3 plus dot dot dot. कितना होएगा? Let's till n, let's say it will be 1 by n, less than red. Red will be what? Integration 1 to n, 1 by x dx, and the green is what? Is, let's check it out. Understand it's 1, 1. Then this half, the height, this is 1/3. Katte katte is 1 by n minus 1. So it's some 1 plus half plus dot 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 1 by n minus 1. Do you understand this, guys? Did you understand this? Did you understand this calculation, all of you? Yeah, sure. So let's put, so they have to understand that from here we get that 1 plus half plus dot 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 1 by n is less than 1 plus integration 1 to n 1 by x dx. From this 2 we get this, and 1 plus half plus dot dot 1 by n is greater than integration 1 to n plus 1 1 by x dx. From this two we get this. Do you understand this, guys? Tell me if you understood this calculation or not. Tell me if you understood this calculation or not. All of you understood this, guys? Okay. So we have got what? So we have got an inequality that summation of 1 by k from 1 to n is less than 1 plus half plus 1 by dot dot n minus 1. Sorry. Is greater than integration 1 to n plus 1 1 by x dx. And it's less than one plus integration 1 by x 1 to n dx. So this is the idea, and let's do this calculation. It's log of n plus 1 is less than 1 plus half plus dot 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 1 by n less than log of n plus 1 log of n plus 1. So essentially, if you see this by n, this by n, log of n by n goes to 0, right? Log of n behaves slowly than n, and this goes to 0, this goes to 0. So you understand that this is much better. Like 1 behaves like log n, logarithm 1 behaves like polynomial n, linear. So logarithm is much preferred than linear. Do you understand this idea, guys? This is very important property in the optimization part of whole thing. Did you understand this, guys? All of you understood this? Perfect. Thank you for your time and all the best and good night. We will be back next week with another problem. Bye.